Alright, this time we're going to be taking a look at another original Mr. Christmas holiday go-round. Pooh and his friends ride around and around to the music of 25 great Christmas carols found at Goodwill for $5.50. So, which is funny because over here it says 10, but it didn't cover the original sticker. So, opened it. Well, let me rephrase that. The person who found it opened it and says complete, but they don't know if it works because you can't get it to work. And there's the receipt to prove it was $5.50. So, what do we have in here? We have Piglet going backwards, and the prop does not move. We have Eeyore in a basket. Piglet was in an airplane. We have Tigger in a boat. And Pooh in a plane with the prop. The prop actually spins. So he's got a better plane than Piglet. And then we have the star, which is right yonder. And there is the base. Let's just check that. Sorry for the dog. And oh, there's a piece of cardboard in here, but I don't think there's anything underneath it. Nope, nothing there. So let's take a look at this and see if we can get it working. Because it's supposed to be a Christmas gift for somebody who likes the Pooh and Friends. First, we don't know if it works at all. It's copyright Disney, Mr. Christmas. Made in China. I don't see a date. Looks okay. Has a lot of play, but it's tight. Here's the bottom. I might be able to read it better if I turn it this way. It is 6-volt DC. And it takes a standard barrel. So, let me go through my pile of stuff and see if we can find a 6-volt DC jack. So what do we got? This should be the size jack. It is. Okay. What do we have here? Sitting on my bench for, well, I have a 6-volt power supply. That's 12. But it doesn't have an end. What do we got? I keep a couple of standard ones in here for using on projects. And no, I don't have one with the same jack, so we're going to have to make one real fast, which isn't going to be too terribly difficult. Here's a plug end, and it should fit. It does. For those who have never seen those, these are called Wago connectors, and I use them for everything. They are designed for house, so you can use them in your house, in the walls as an example, for power, things like that. I use them in light fixtures when I can't get wire nuts in there. I also use them in ceiling fan fixtures when I can't get wire nuts in there, and I use them a lot for testing. First thing I'm going to do is clean these ends up. They're pretty horrible. how these work is whatever you put in here is all on the same bar, which is why I have two of them. So I'm going to put the black wire in one. You just click it down and it's good to go. And put the white wire in the next one. Now, if you're not sure, you don't want to reverse the polarity, especially on anything that's DC when it comes to electronic stuff. In some cases you're lucky and you won't hurt it. Other cases you'll pop a component on the board. So we're going to check to see which of these is hot. So I'm going to put that in there, and then I'm just going to... So the white wire is not. Or I don't have a good connection. There we go. So I have resistance on the black wire to center. And no resistance. So black is the hot, white is the negative or not. And on these, normally there's some sort of marking. There's a white line that's dashed on one wire, and the other wire has text. Now, it can vary. I have seen it vary, but generally the white dashed one is hot. So we're going to test it just to make sure that this cheap Philippines power supply is correct. So, volts, and this one is the non-painted with the white dash, and this one's the dashed, and we get no power. Might be a bad power supply. That, or it needs a load. Alright, so we're not going to use this power supply since I'm not getting any juice. Might have been one destined for the trash can and it never made it. So, I'm not going to use the Wago connectors. I'm just going to use the alligator clips from my my power supply. One thing that would have been nice about the AC adapter working is, since this is missing it, I could get a male end, stick it on, and then send it out with the power supply. So I probably have a lot more, just not in the laboratory. Alright, so my meter is set for 6 volts, excuse me, my power supply is set for 6 volts. And it's DC, so we're gonna white is negative, black is positive, just to confirm. It's always better to be safe than sorry. Six volts, and if I reverse this, it'll have a minus 6. So a voltmeter, whether it's analog or digital, works great. The analog ones generally make the needles peg backwards. Some of them don't have a negative voltage on analog, some of them do. Apparently the on-off switch is broke. It's not in its hold. So let's see if it's on. Apparently it's not on. So I am going to have to open this. But let's see if I can get this switched at least to flip, just to test it. That might be why it went to Goodwill. It probably broke and they couldn't fix it. trying to do is wedge it so I can flip the switch. I think it moved. Let's find out. Nope. All right, let's take it apart. That's usually the whole reason we're here anyway. I don't know if these screws actually do anything other than hold the feet on, but we're going to start with the screws. Take a look. Alright, based on the length of this stud and the depth of this rubber, these screws do nothing more than hold the feet on. So, we're going to stop there, and I'm going to assume it's like a standard carousel. I know there are some carousels that are different, that you can actually take apart from the bottom, but we're going to go with a standard style carousel, and I'm going to look in the top where this plug would go in for the star on a stick. And we're going to see if anything's in here. And no, it's hollow all the way down. And if you hear foots, that would be the dog. Decided to open the door and come on in and say hi. Because dogs don't care if you're filming or not. So, there is a seam all the way around with some glue. And I'm going to see if I can get enough leverage to start popping the glue. If not, we'll apply some heat. Just need to see the bottom again. You can see there's some glue here. And we got glue all in here. We have a gap of glue right in here. Right above the power port. There's a gap of no glue. So... see what we can do. All right. This screwdriver might be too big. All the way down. Oh wait, no. I probably just didn't have a long enough screwdriver. There's something there. I'm going to try something crazy. This is an inspection camera. I'm going to see if I can look inside here and see what's down there. Because again, my goal is not to destroy this. My goal is to fix this. And I want to do it right without damaging the resin. So, apparently it's dead. Bear with me, I'm going to go grab a charger real quick, plug this thing in, and we're going to look inside here. Alright, we're back. Got a charger And you can see by that it works. And there's the light. There we go. Now let's take a look inside there and see what's in here. Now it's a little out of focus, but yeah, way down in there is a Phillips screw. And it looks to be a number 1. So I need to find a number 1 with a long shaft. Because this one doesn't reach. Because it only goes in that far compared to the other. And if I remember right, my number 1 got lost. So I might have to go out to the shop and grab a long one. No. I think that's also a number 2. Yeah. Alright, yeah, they're both number 2s. So, I'll be back again in a moment, because apparently everything I'm trying to do, I don't have preparation for, because everything's changed. It's what happens when you don't do a lot for the last month due to a hand injury. This is a number 1. It's actually a little bit smaller than a number 1. I'm going to see if this will grab. Nope. Oh, wow. This one's grabbing, but it doesn't have enough torque because the handle's so small. So, let's cheat and increase the torque. Yeah, it's jumping threads. So, one of two things. Either this screw is not designed to come out, or they use glue on it to keep it from backing out. So, I turn this off so we quit wasting power. And I'm going to go through my screwdriver assortment, see if I can get the break free. If not, we'll heat the bottom up and see if we can get the bottom off. But I have a funny feeling the bottom will not come off, because it looks like it's assembled like a standard carousel, where it's attached, and this canopy is actually glued on, as you can see right there. And that is hot glue. It's all spongy. So if the canopy has to come off, the canopy has to come off. Use hot glue, fix it, good to go. So clean up the workspace. Future video. And get this apart. So be back in just a few moments once I get some more tools and see what we can do. Okay, after several minutes of playing around with it, here's that little stupid screw. It is a number 1 machine screw, and the top comes off. And yeah, that was a pain. Down inside the neck here is 1, 2, 3 screws, which are also way down there. Now this screw, the head to the top of this is 3.5 inches. And this one is 4.5 inches. So you need some long screwdrivers. Ooh, this one's not quite 4 inches. Let's see if I can get in there because these are number 2s. Yes. So just be aware, if you have this piece and you have to disassemble it, pull the star out of the top if you had it in there. Unscrew that with a long number 1 and then pull it off. And then inside here is 3 number 2s. So this does come apart similar to a carousel, top down. Either these are really long screws or they're just caught in the plastic. I think they're just caught in the plastic. Yeah. One. 2 and 3. So they're not too long. They're just aggressive thread, and they were caught in the plastic. Now, there's 4 fingers that apparently have a little bit of glue on them. So I'm just going to try and pull them with my finger. Look in there, you might see the 4 fingers. There's a thin blade here. Make sure they're broke free of their glue. So apparently I got 3 of the 4 broke free with my finger. Not all 4. See the gearing. I have a funny feeling it's also glued in the bottom because there's no way this can come up through the top. Nope. So it has to come out the bottom. Just going to see if the center shaft comes up. No. Center shaft, which is what the screw was into in the middle down there, is still attached. Some of the glue. So this is quite a invasive process to get this one apart. They used a lot of glue. Looks like there's more glue down inside. I'm going to use a set of magnifiers and take a better look. Yeah, they glued even farther down. So below those fingers and between them, there are dabs of glue. At least on 2 of the spaces. Unless you're like a super Winnie the Pooh fan, you may not want to try and fix this one. I usually don't say that about many pieces, because this one is going to be a very, very, very challenging piece. Looks like the bottom has to come off next. The green piece may be glued in just as an anchor point. So before I continue separating it, I'm going to have to separate this base, which is glued 300 degrees out of this 360-degree circle. They really do not want you inside of this one. That or this one's very special, and they said, you know what? We don't want whoever gets this one to get into this. Because, holy smokes. What I'm doing right now is just assessing the situation of the glue, looking at the double seam they have here, and just processing how to possibly get into this. Best plan of attack. Also, just in case it matters, I'm going to put a little red mark on it for an alignment. Just because it's a circle doesn't mean that the insides are a circle and fit correctly. You might have multiple positions. So the 6-volt power port, I put a little red line so I can line it back up if I can get it apart. Big if. So far I've been able to get everything apart. I have not been able to fix everything, but I have been able to get everything apart. So I see by examining it, there's a gap in the glue right here, right here, right here, and that's it. So I'm going to try and put some pressure on these gaps and see if I get any movement whatsoever. I'm getting a little movement here where the 6-volt power port is. This resin appears to be flexing. What do I get between them? Nothing. I get nothing here either. So I'm going to try an X-Acto knife and see if I can cut into the glue and see if that helps. Worst case is we'll have to fire up the heat gun and give it the heat treatment. The reason I'm going to try and slice a little bit first is resin and plastic, certain heat temperature, instead of coming apart, you're going to start melting, and when you pry on it, you'll distort it. And because this has a lot of resin around it, I have a funny feeling the melting point of the glue probably is higher than the melting point of the resin. I did actually get some movement, so let's go around it one more time. A little bit more pressure just to ensure I'm cutting through the glue. There's a piece of the glue. I don't know what kind of glue this is. It's very weird. It's kind of a white glue, maybe like a silicone, and that is starting to move a lot. So, can I get the spudger in there at all? No, it's too wide. What do I grab the Phillips? There we go, 2 blades. This kind of reminds me like you're de-beading a tire. There's actually a lip as well as the glue. What I'm trying to do is get the lip to pop over the base. for sticking with me this far and actually watching it and not skipping ahead. Me and a co-worker have an ongoing thing about blade screwdrivers. I call them blades, he calls them flatheads. I learned that they're both correct growing up. What do you call them? Like most people call them a Phillips and not a cross tip for the other style, because Phillips is a name brand and cross tip is apparently the correct pronunciation. What do you call your screwdrivers? And do you abuse them like this, where you don't use them as screwdrivers, use them as prying things? I wear more screwdrivers out prying and scraping than I do actually using the screwdrivers when it comes to the blade or flatheads. It's also how you break them. But I don't use my good screwdrivers when I'm doing stuff like this. Now, this is going to be a long, tedious process. I have gone, 4 inches, and it is coming out. It is separating. It's separating the glue that's remaining, and it's coming out from its lip. So I don't know if it's going to pop at about the 50% mark, like a tire will, or if I'm going to have to walk all the way around this thing. But from here to here is now separated from this resin base. So instead of boring you with more prying and talking, I'm going to pause it till I get all the way around this thing. At this rate, it's probably going to be 20 minutes or more. And then come back so we can get to the heart of this machine and see what it's going to take to fix it. Okay, it's taken me a little over 10 minutes. Here's the glue. I've not pulled it out yet, but this is the glue. I used heat, the razor knife, and the screwdrivers. There we go. Fun. There's that. And it's broken plastic because right there, the screwdriver punched through on the ring. There's 2 layers of glue. There's some glue here, and there's some glue here. What a pain in the ass. This is not designed to come apart. And I mean that with the most sincere, they do not want you in this one. At all. Forever. So, let's get the circuit board off so I can get to the on-off switch, which is below it. That is also a number 1. So it looks like we got 3 screws. We'll take a look at these gears since I did spin them, trying to get the screw out of the top. Make sure all the teeth are good, because it's got a worm gear set up, and worm gears do not like to be driven backwards, meaning they drive the gear does not drive them. So we'll check those out in just a moment. Alright, there's a little bit of glue on the circuit board, which is no surprise. There we go. They glued this smaller screw and this screw over here. So here's the off-on switch that came free because the plastic has bent. I'm going to turn the switch on and plug this thing in so we can hear it. Switch is now on. Belt looks okay. Oh yeah, let's inspect those gears real quick. Looks like it might be cracked. Yes, the worm gear, which is this one right here, is split. Not good. Let me check the others. It's split in 2 places. Imagine that. But the big gear that goes around this shaft looks okay, and then these 2 gears here, which I just forgot the name when they're at a 90-degree angle like that. It's like a torsion gear or something. They look okay. So let's plug her in. Let's turn the volume down a little bit. The motor does not appear to be turning. It's really tight. I'm going to take the belt off. That motor is just not liking things. Hey, it's starting to spin faster. Look at that. I don't know if you can see it. It's silver disc right here at the bottom of your screen. So this might need a full rebuild. Trying to get the belt back onto the big pulley. Motor starting to increase in speed. Oops, my leads are shorted out. You recognize the music. I hope you're liking it, because I don't. Apparently you don't want this big belt coming off this pulley. It's not the easiest to get back on without taking it apart. There we go. Look at that. Well, you can see the gears spinning. See if it has enough tension to spin the top. There we go. Still gonna have to replace that gear. Speaker doesn't sound bad. Let's turn it up a little. Now it's starting to sound bad. All right. Just flip to the Christmas carols. The new song selector doesn't work. new... Wait, now it worked. So, it's got some issues. Alright, so the new song selector doesn't work. The screw on the volume wheel is loose, which is now tight. The power switch is broke free. The speaker distorts at full volume on some tones. The motor has got a slow start. So I'll plug it and see if it'll restart here in just a minute. I'm going to see if I can get this to fit back into its fingers and we can re-glue it in, just like it was originally. Because the finger clips are still intact. I think it's because the glue failed. That's one of the reasons it fell out of its socket. One of the backers is bad. That's another reason. And did I plug it in the right way? Nope, switch is upside down. Alright. So yeah, now we know why it's at Goodwill. It's because this thing has a lot of issues, and it's one of the hardest ones I've ever had to open up. Yeah. I don't know if I'm going to use hot glue to hold the switch in or if I'm going to super glue it, just to make sure I get a really good bond because of the pressure. There we go. Motor started right up this time. Now the box says this runs at 400 milliamps. Right now it's running at 500. Now 600. Now 500. So this is drawing more power than it's supposed to. Could be because the motor is starting to fail with that slow start. That's what I'm going to go with since there's no lights. The song selector still isn't working, which could be a bad switch or a bad wire. Just trace it onto the circuit board. We use these because these are non-conductive. This solder joint right here are the switch selector, or the switch selector song selection switch. And on the board it says SW2 for switch number 2. So it's got 3 switches. They actually melted the plastic around the wires. That's why there's not a lot of slack. A lot of times they just glue them. I mean, it's literally dissolved. Which also could be heat. This is Arizona. Things get really hot. What I'm doing right now is I'm just doing a visual inspection of the capacitors, the transistors, resistors. I'm looking for any damaged components. Bulged capacitors, leaking capacitors, chipped or cracked transistors, resistors that have changed color because they've gotten hot. There's a diode. The back of the speaker, where the rivet is, they riveted that little panel for the 2 wires, is corroded. So at one point this was in a moisture style environment. Circuit board looks good. Try to get you a little bit of a view. But we are going to have to disassemble all of this because I need to see if I can replace that worm gear. I know it's working right now, but it's got 2 cracks. Cracks don't get better on their own. Say no to crack. Off on switch works. So those are number 1s. Looks like we just got 4 screws to hold in this whole assembly. See if I get it out, I can possibly show you the cracks better. Of course, we have the motor wire is glued and melted into the plastic. Jeez. So, yeah, take a gander in here. There's glue, and that's actually melted. It's actually notched into the base. You can see it's gotten hot there where the motor's been sitting. The 2 contacts there. We got glue here, and we got glue and melted plastic right in there. And let's rotate this. We have a hairline fracture right here. And we rotate it again. You might see this one better because you can see the little green line, I hope. That's where the green grease has gotten into the split. So they're split about 90 degrees off of each other, but they both go to the center spiral of the gear. So at any point the gear could connect. So give you a better idea. This is round. So let's say this flat here is one crack, this flat here is another, and they're like this. At any point they could connect and that gear would come apart. So we'll have to address that. This motor is an RF-500T, like Tom, 8-12560. So, and it's probably Chinese. I don't recognize the symbol that's next to it. So, if I have another 0.5, wow. Most speakers, if you watched a lot of the different repairs, Lemax, Mr. Christmas, etc., most speakers in these things are 0.5 watts or a half watt, 8 ohm. This speaker is a 0.5 watt, 16 ohm. So that is very different. I do not have any 16 ohm speakers. Everything I have is between 2 and 8. So, yeah. Very interesting. Very unique. I don't know what year this piece is. I'm assuming it's very old. It sure looks like it based on the type of wire they're using. And 16 ohms seems like something that'd be way back in the old day. What I'm doing right now is I'm trying to separate all the wires from their glue and melt. And that way we can see the other side of the circuit board and have some slack to work on this thing. So the other side of the circuit board, which I'll show you here in just a second. 1998. Mr. Christmas, copyright 1998 on the blob chip board. So, that's, what? It's going to be 2022 here in 30 days. So that's 24 years old. Yeah, this is an oldie. And yet, it still kind of works and technically is repairable. So, just cutting off some of the glue. It's really sticky. And I know some people are like, oh, it's glue, it's supposed to be sticky. Well, usually when glue is 24 years old, it isn't sticky anymore. It's usually hard. So here's the circuit board. Here's the motor right there, which says M1 for motor 1. This only has one motor. This says speaker. So if we follow this wire, it goes all the way down here to the speaker. This says SP1 because they use code. This says VR1. The VR1 is a 3-wire for the variable resistor or potentiometer, which is your volume knob. That's the 3 wires. The red and black wire says PWR, which of course is power. Then we have switch 2, which goes to actually the Christmas Carol switch. I thought it was the other one. Now that I have the board out, I can see it better. The wire here, which I cannot read what it says under the glue, it probably says switch 1 to be truthful, goes to the button. And that's the one that's not functioning. So I'm going to assume it's the button. Because if we trace it through the board, one wire goes to the blob chip, and the other one goes to the other side of the blob chip, but also connects with the negative. So I'm going to assume it's either going to be a bad switch, since it did work once, or the signal to the blob switch is bad. Which, if it is a bad blob chip signal, there's not much you can do. These are proprietary chips. You're not going to find one, especially since they're coated in a resin. So this chip right here, this 8-pin guy down here in the corner, I would assume would be a power amplifier chip. It is a 386D like David by JRC. So we can always look that up to see what it is. But if it's like most of these, that would be the volume control. That would be the amplifier for the speaker. Especially since the speaker wire is right here. I'm sure if we trace these contacts, yeah, pin number 5 goes right to the speaker wire. So that would be your speaker amplifier chip. We got a few transistors and capacitors. They all look good for this thing being as old as it is. There's no real corrosion other than a little bit right there on the speaker, which we'll see if we can bring it up. If you look at that rivet right there in the center, hopefully you can see it with my fat finger. It's green. That's actually corrosion. It does come off. Yeah. So, we can test this switch, see if it's bad. We do a continuity test. We put a meter on there, press the button. If we get continuity, switch is good. We press the button and the meter still shows open, then the switch is bad. And if that's the case, it's a momentary switch, which means it's non-latching. You press it and it disconnects when you let go. And we can probably replace that without any problems. As far as here, we have a broken gear. So we'll have to disassemble this piece right here, the lighter white, and get this off and check my worm gears and see if I have one that's the same diameter. This worm gear is a cylindrical worm gear. Where is a piece of paper and pencil so I can describe it better with an image versus we'll just use that. So that's what this has, if you're looking at it from above. A lot of worm gears I have are shaped more like this. Now worm gears can, like this, wear into this pattern, but some worm gears come with this curve to help keep the gear straight in the middle, and the gear that comes on the side, with all its little teeth, pardon me for my horrible drawing here, more of the teeth are in contact with the gear than on this style. So, but if I put this style on here, it will not touch this shaft. So it has to be this more squared or cylindrical style worm gear. So that might pose a small issue, but we'll see. So now it's time to try and locate some parts. What I'm going to try and locate is a gear, and we'll do an ohm test on this switch. I think we can do that right now. And if that's the case, then I know where the switches are. I have a whole bucket of them. We'll have to glue this back in, which is the power switch. Let's move this out of the way. We're going to set this to resistance. See, can I put the sound back on? Sound on. There we go. Oops, sound's not on. Alright, so no matter what pin configuration, I'm getting open with no depressing of the switch. So let's depress the switch. This is where a third hand would be nice. Okay, switch is depressed. Keep slipping. Try that again. Now unpress the switch, and now I have resistance, and you can see it slowly dropping. I think we got a bad switch. Also, the resistance should be 21 ohms. So switch is pressed again. So it spikes at 20 ohms and drops down to 0.6, 0.7. Yeah, most switches have a very low resistance. Switches are off, and it's lingering at 0.6. Yeah, we got a bad switch. So we'll have to pry this out of its groove after we break the glue joints at the top. Solder on a new switch and see if that fixes the problem. All right, now let's try and find some parts. Get this thing disassembled and reassembled and see if it fully functions with sound, switching capability, and motion. And now that we have this out, there's one little crack right there. Hopefully you can see it. And there's the other crack right there. And this gear and this gear are separate. So if I can find the correct diameter and shape, I can just unpress or pry this one off and slide the new one on. And then they used grease in between, grease on the shafts. One side's turned green. I'm assuming it's turning green because this brass fitting is corroded. And brass, just like copper, can turn green when it gets exposed to moisture for long periods of time. Caught everything. So, I'm going to wipe off this grease. And I'm going to pull out my gear bin. And we're going to see if we can find the gear. And I'll get a switch out. We'll go from there. There we go. All back together. Let me find the volume knob. So, we now have a fully functional carousel type piece. Here's the broken one. I did have a replacement, and I did have to replace the belt. Once I put tension on it with the new gear, this belt was just slipping. You can kind of see the white color. That's the vulcanization of the belt, and you can see it's kind of stuck in a teardrop shape. So I replaced the belt with a same original size, so slightly smaller than this because this is stretched. Same thickness, because it's a relatively thick belt. It's just not black, it's kind of a tan color. As far as the selector switch, nope. Selector switch is apparently not the switch, it's the board, because it doesn't matter. New switch, old switch, no switch, it doesn't change songs. So that component on the board that reads it has apparently gone out, and there's nothing I can do about it, unfortunately, but it now spins, plays music. You can select between Christmas and non-Christmas songs. There's all the characters on it. You can see them on the outside edge. And one of the things about this is each one of these branches is notched, so you can actually move the figurines because the branches are different sizes. That's a fat one. That's a really thin one, medium, 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 medium. It's just the casting. I don't know what the point is, but I do know if you want to keep this balanced, you need to go every other one, or else it's not going to be balanced. The corrosion, the green corrosion on like the gear that I just threw away, is because this actually uses brass bushings on the end of the shafts for the gears, and the grease with the moisture and the shaft, it creates basically verdigris. The bottom pulley where the belt was changed from, same thing. The once I pulled off the bottom pulley clamp, which is similar on almost all animatronic houses, there's usually if it's on an open pulley, there's a bar that goes across it, and it's just a screw, sometimes two. You just loosen them, and then you can pull the belt off. That also has a bushing pressed into it, so the bottom pulley stays centered. That way it doesn't wobble, because there's a lot of torque on this. This is actually pretty heavy resin, so there's a lot of torque. But I don't know why it didn't start. That was weird. That was the first time it didn't do that. I might have to open it back up and take a look. Maybe the new belt's slipping already. So I'll run some tests on it. But this is one of the hardest ones I've come across as far as disassembly or repair, because you have to cut the bottom out, and there's 2 layers of glue, and the screw that's in the top was also a pain to get to. It's underneath this star. But it does use a standard size worm gear on the cylindrical side, not the tapered ones. It's a standard length. You just have to press it on. No, I press it on using a vise. So you just put the shaft and you squeeze it together with the vise. That way you can hold it parallel, so that way you don't shoot it off at an angle or crack the gear. You can get equal pressure. You can use pliers too. You want to use pliers that closed together, like slide locks, stuff like this, because of the angle. You don't get equal pressure. Which is why I use a little bench vise. Or a jeweler's vise will work too. But yeah, if you have this piece and you need to open it up and repair it, it's going to take some time and some work. You definitely should probably use heat, a X-Acto knife for the bottom. Pop the top out. You need a long shank #1 screwdriver, such as this. Then you need a long shank #2 screwdriver to get to the 3 bigger screws. And then you just have to fight that bottom. And it's going to take you some time. Be patient. I did crack the plastic. I did put super glue on it. That's why I'm not lifting it, so it's going to harden. Because I put a very thick layer of Gorilla Glue on there, so it can cure. I also repaired the on-off switch that was flopping on the inside. The 2 locking standoffs had broke off, so I just glued them with super glue. And they're still hardening because I didn't put on a thin layer, I put on a very thick layer. I thought about using their standard glue, the standard Gorilla. This takes about a day to set, but I figured the super glue will be fine. I've never really had too many issues with it failing. So as far as this one goes, if you do own this or something similar, you're going to have a hard time getting the bottom off, since they use 2 layers of glue, top and bottom ridge of the base. You have a deep recessed screw, #1 Phillips again. Then you have 3 deep recessed #2s. And then you just have to literally just pry on this bad boy to get it apart. And take your time. Once it's apart, the rest are all #1 screws for the most part. Take it apart so you can get to the gears. And the gears, they're relatively standard. The Iuki gear pack from Amazon has the worm gear. And even has the big pulley, not the small pulley. But the, I think they're called tension or torsion gears. The 2 gears that change 90 degrees, they're not in that pack. But if you look them up, you'll probably find a hobby pack that includes them. And the belt, I just used the belt that came with that Iuki gear pack that I've shown in other videos. It comes with 5 belts. And the tan belt, because they're colored, the tan belt was the right size. So, but other than that, it's not easy, and hopefully this will help you with these hard ones. Because yeah, what I have to do to it now is if it sticks again, I'll have to open it up and see what's not moving. Maybe the motor. I didn't change the motor. Once I load tested it when it was open, it was working fine. So maybe the motor's slipping or dying, or well, it's not the power supply, because this power supply can pump out 2.5 amps, and this doesn't draw that much. So the only thing I have to do now is find the correct power supply, so it can be plugged in and moved around as a centerpiece for a table. And try and tip it a hair. I don't want to throw it off balance too much. We're going to turn it off for a second, so that way you can see the tree says Holiday Go Round. And I'm also going to try and clean up this. This right here is melted styrofoam from when it was in a box, or the box. So, but anyhow, thanks for watching for the Holiday Go Round, Pooh and his friends. So, oh, and one last thing. The reason Piglet's doesn't spin and Winnie's does, see the red dot? That's a pin, a plastic pin that holds the impeller in, or excuse me, propeller. That one's been missing and somebody put glue on it, so that's why his doesn't spin. So if you have this piece, it probably spins. On Eeyore and Tigger's cart and boat, respectively, there's no moving parts. Everything is just solidly cast. So only Piglet and Winnie the Pooh would have the rotating pieces. So, alright, thanks for watching. Until the next repair, have a good one.